In this question, potential for an anisotropic harmonic oscillator is given. The question is asking to determine the ground state energy. So potential is of the form 1 by 2 m omega square x square plus twice m omega square y square plus 8 m omega square z square. Now we would be writing in terms of isotropic oscillator, that is m omega square x square plus 1 by 2 m into 2 omega square y square plus 1 by 2 m 4 omega square into z square. So we would be writing like 1 by 2 m omega x square plus 1 by 2 m omega square y square omega y square plus 1 by 2 m z square into z square. So now this potential is expressed in the form of isotropic harmonic oscillator. So for isotropic harmonic oscillator, energy is given by E and X, E and Y, E and Z, E and X plus E and Y plus E and Z is equals to E and X and Y and Z equals to Nx plus half H cross omega X plus Ny plus half H cross omega Y plus half H cross omega Z. So Nx plus half of H cross omega X was equals to omega and Y plus half H cross omega Y is equals to 2 omega plus Nz plus half H cross omega Z was equals to 4 omega. We can check it out here. So omega X is equals to omega Y is equals to 2 omega and omega Z is equals to 4 omega. So that means Nx plus half H cross omega plus 2 Ny plus 1 is equals to H into H cross omega plus 4 Nz plus 2 is equals into H cross omega. So our energy would be Nx plus 2 Ny plus 4 Nz equals to 1 by 2 plus 3 H cross omega. That means Nx plus 2 Ny plus 4 Nz plus 7 by 2 into H cross omega. Now for ground state, we have to determine ground state. For ground state, Nx equals to 0, Ny equals to 0, and Z equals to 0. That means E0, 0 is equals to 0 plus 7 by 2 H cross omega equals to H cross omega. In this problem, the product of uncertainty delta x, y, z in the position and momentum of simple harmonic oscillator of mass m and angular frequency omega in the ground state is h cross by 2. That means, so the question is asking the value of product of uncertainties delta x and delta p in the state IPL H cross 0 would be. Now Initially, our psi is 0, and that means delta x is expectation value of minus del x square for this stage 1 by 2, and delta p is similarly 1 by 2. For this state, if we calculate delta x and delta p, we would be getting projected delta x delta p is equals to h cross by 2. Now, question has changed psi to e to the power I p minus I pl by h cross into delta 0. Now that's the question defined psi. And for this psi, we have to determine delta x and delta p. So let us check what would be the change in x if for this psi. So if I take psi x psi, in that case e to the power I pl by h cross 0 x 0 e to the power minus I pl by h cross is equals to 0. So we can check it up. There is no change in average value of x due to the presence of exponential term. Similarly, the value p would be 0, x square and p square for psi would have same value as we obtained for state zero. Thus, the product of uncertainty in position and momentum would also be same. That is delta x dash delta p dash is equals to delta x delta p is equals to h cross by 2. Thus our option C is correct. The wave function of an electron in an hydrogen atom is defined as 1 by root 6 phi 200 r plus root 2 by 3 minus 1 r 1 by root 6 phi 100 r. Since psi r the normalization value psi r is 1 by 6 plus phi 200 r phi 200 r plus 2 by 3 phi 21 minus 1 r phi 21 minus 1 r plus 1 by 6 phi 100 r phi 100 r. That means 1 by 6 plus 2 by 3 plus 1 by 6 equals to 1. So psi r is normalized. The expectation value of energy would be r is equals to 1 to n Pi, Ei, here probability would be phi 2 E2 into 1 by 6 plus 2 by 3 into E2 plus 1 by 6 into E1. So these are the energy. Now E2, E1 we defined as minus R infinity Hc by 1 square, and E2 would be defined as minus R infinity Hc by 2 square. So we can write E2 as E1. This term is equals to minus 13.6 EV E1 by 4. Substituting the value here, E1 by 4 into 1 by 6 plus 2 by 3 into E1 by 4 equals to E1 1 by 6 into E1. So it would be equals to 9 E1 by 24, which can be written as 3 by 8 E1 equals to minus 3 by 8 into 13.6 EV, which is equals to minus 5.1 EV. So the expectation value for the given wave function of an electron in hydrogen atom is equals to 5.1 EV. So let us check which option is correct. Option D is correct. Three identical spin half particles of mass m are confined in one-dimensional box of length L, but are otherwise free. Assuming that they are non-interacting, the energy of lowest two energy eigenstate in unit of pi square h square by 12. So we are having three fermion, three identical spin half particle, that is fermion. Distribution three particle in lowest two states are states are let this is equals to n is equals to 0, this is equals to n is equals to 1, n is equals to 0, this is equals to n is equals to 1. So initially distribution of electron is like this, and in the next stage electron moves like this. So this would be ground, this would be excited, and energy in ground state is E0 would be 2 into pi square h square by 2 ml square into 1 into 2 square pi square h square by 2 ml square. That means 6 pi square h square by 2 ml square. Energy of the particle excited state is E2 equals to 1 1 into pi square h square by 2 ml square plus 2 into 2 square pi square h square by 2 ml square. That means 9 pi square h square by 2 ml square. Thus, our correct option would be 6 and 9, that is option B. Consider the operator AX defined as Ly Pz minus Lz Py, where L and Pi denotes respectively component of angular momentum and momentum operator. We have to determine the commutator AX with X. AX with X. Now we can simply write it down. The value of AX, Ly Pz minus Lz Py with X, we would be having it Ly Pz X minus Lz Py X. So now we can have Ly Pz X plus Ly X Pz minus Lz Py X minus Lz X Py. We know X Pz X Py is equals to 0. Ly X is equals to minus I h cross z and Lz X is equals to I h cross y. Substituting this value here, we would get Ax X is equals to, first term is 0, 0 plus minus IH cross Z to Py Z into Pz minus 0 minus IH cross y into Py. So we would be having minus IH cross Z Pz plus y Py. So Ax, commutator of Ax and X is equals to this one. That means which option is correct? Option A is correct. This problem is related to JWKB approximation, in which a one-dimensional system is described by Hamiltonian H. The ground state energy is varies as a lambda. So I am writing here one important relation for general potential of the form V of x is equals to lambda mod x की power m, giving Hamiltonian p square by twice m plus lambda mod x की power n. The energy dependence Em on lambda and quantization number n are as follows. Em is proportional to lambda 2 divided by m plus 2 and n plus half to 2m m plus 2. Now from question m is equals to 1, so E1 is proportional to lambda 2 into 2 plus 1 and n plus half proportional to 2 into 1 plus 2. That means lambda 2 by 3 and n plus half 2 by 3, which means our option B is correct. If the position of the electron in ground state of hydrogen atom is measured, the probability that it will be found at a distance r greater than a is nearest to. So we have to determine the probability of finding the electron or particle. The probability of finding the electron at r greater than a naught is P r greater than a naught is 1 minus P r less than a, which can be written 1 minus 0 to a more psi square into d2. This can be written as 1 minus 0 to a 4 pi r square. Now psi 100 is pi a naught cube root minus r by a into dr. Psi 100 for ground state is root pi a naught cube e to the power minus r by a0. That means 1 minus 4 by a0 cube 0 to a e to the power minus 2r by a0 r square dr. Let us evaluate the value of this integration. 0 to a e to the power minus 2r a0 r square dr equals to I. 2r by a0 is equals to t implies r is equals to a0 by 2 into t. That means tr is equals to a0 by 2 into dt. Further, as r tends to 0, it tends to 0. As r tends to a, t0, t tends to 2. So our integration reduced to 0 to 2 e to the power minus t a0 by 2 square t square a0 by 2 dt. That means a0 by 2 cube 0 to 2 e to the power minus t square dt, which is equals to a0 by 2 cube e raised to the power minus t minus 2 minus t square 0 to t. This whole term, after substituting the limit, we get a0 cube by a0 cube a naught by 2 का whole cube into 2 minus tan e की power minus 2. Substituting the value of I in the equation for probability r greater than a0 is equals to 1 minus 4 a naught cube into a naught cube by 2 to 2 minus tan e की power minus 2, which is equals to 1 minus 0.3233 or equals to 0.66. So our correct answer for this question would be 0.66. Option B. A system of spin half particle is prepared to be in the eigenstate sigma z with eigenvalue +1. This system is rotated at an angle 60 degree with x-axis. After the rotation, the fraction of particle that will be measured in the eigenstate psi z with eigenvalue 10. Now, the eigenstate corresponding eigenvalue sigma z equals to +1 for spin matrix sigma z is, so we denoted psi I initial for up state equals to 10. Now the system is rotated along x-axis. So we define Rx theta matrix as Rx theta equals to cos theta by 2 I sin theta by 2 I sin theta by 2 cos theta by 2. So the final state of the system after rotation about x-axis is psi final be Rx theta into psi initial. Rx theta would be cos theta by 2 I sin theta by 2 I sin theta by 2 cos theta by 2 10. That means cos theta by 2 I sin theta by 2, which can be written as cos theta by 2 in up state plus I sin theta by 2 in down state. So that is the probability of finding particle in spin up state is cos square theta Theta is, I think, 60 pi by 3. So cos pi by 6. Cos pi by 6 is root 3 by 2 square, that is 3 by 4. So let us check which option is correct. So option D is correct for this problem.